My name is Dorina Bano and I am a PhD student at Hasso-Plattner Institute, University of Potsdam in Germany. More specific, I am part of the Business Process Technology Group supervised by Professor Mathias Weske. Today I'm going to present our paper in the scope of the ER conference called Discovering Data Models from Event Logs. And I would like to start my presentation with a short motivation. Why we need such models. And in traditional process mining, we do have a database, which is the starting point, and then we start to extract an event logs. And after the event logs are extracted, then we can discover process models, which tells us in which order the activities are executed in order to achieve a certain business goal. For the moment, suppose that we do not have any idea about the database. We just have an event log, but we are still able to discover the process models. So the event logs captures behavior information, and we argue that they are also a rich source of domain-specific information, which cannot be explicitly discovered or shown in the process model. That's why we think that it is important to also discover a data model from an event log as a complementary information of the process model, which will help us to better understand the process model and the event log at the same time. Now I will explain you our approach for discovering a data model from an event log. We are using a two-step semi-automatic approach when in the first step from an event log, automatically we construct an activity attribute relationship diagram. As the name of the diagram implies, this shows the relation between the activities and attributes in the event log. And in the second step, with the help of domain knowledge, we try to discover a data model from activity attribute relationship diagram. Now I will explain you in more detail these steps. So the first step, we start from an event log and we would like to construct an activity attribute relationship diagram. The first thing that we have to do is to identify the activities from this event log. And this example of event logs, we have two activities, activity A and activity B. And on the second step, we have to identify the attributes of this event log, which are 4 attributes in this case. And the next one, we have to identify the relation. So if an activity writes a value to an attribute, then we are saying that there is an access relation between this attribute and activity. And last but not least, we have to identify the occurrence, which means that how many times this relation holds in the entire event log. And the second step, we wanted, with the help of a domain knowledge, to discover a data model from an activity attribute relationship diagram. Discovering a data model from activity attribute relationship diagram, it means that we have to discover data model classes, attributes of these classes, the relation between them. And for that, we have applied a set of rules which are categorized based on the 2 aspects: isolated attributes, non-isolated attributes, isolated, non-isolated activities. And attribute is called isolated if all activities that are accessing these attributes do not access other attributes. And the same holds for activity. An activity is called isolated if all attributes that it accesses are not accessed by other activities. And in the first rule, we are going to see isolated attributes and isolated activities. And as you can see, we have activity A, which is accessing attribute 1, and activity B, which is accessing attribute 2. They are both isolated. So in this case, we are going to group these 2 attributes in the different data model classes because we do not have more information. And we can't judge if they might be together in one class. And in the second rule, we will have a look on the isolated attributes and non-isolated activities. So now the question is, should these attributes belong to the same data model class or the different one? And again, the attributes are isolated because the activities that are accessing these attributes do not access other attributes. And that's why, the same as the previous rule, we will group these 2 attributes in the different data model classes because we do not have more information. And on the next rule, we will have a look for non-isolated Attributes and isolated activities. For example, we have an activity A with the same occurrence, it accesses attribute 1 and attribute 2. And we have the same activity with occurrence epsilon is accessing attribute 3 and 4. And with a different occurrence, it's accessing attribute 5. Now the question is how we can group these attributes into the data model classes. Some might think that it looks easy. We do have one activity, and with the same attribute, with the same occurrence, this activity is accessing 2 attributes. So most likely, attribute 1 and 2 might be grouped together because they have the same occurrence, and 3 and 4 together. But this is not true, and it's not that trivial, because the fact that activity A is accessing attribute 1 and 2 with the same occurrence, it doesn't mean that we are talking for the same events, even though the occurrence is the same. If one activity with the same occurrence accesses several attributes, it is important to identify that we are talking for the same events. And if the events are the same, so whenever activity A is access attribute 1, for the same event is access attribute 2, then we are saying that these 2 attributes can be grouped into one data model class. And if this is not the case, if they are completely disjoint, so whenever attribute A is accessing, activity A is accessing attribute 1, in completely different cases, the same activity is accessing attribute 2, then we will store these 2 attributes into different data model classes. And if we see that there are some events in common, then again, we are going to store them in 2 different data model classes, but we are saying that there is a relation between these 2 classes. This is all about non-isolated attributes and isolated activities rule. And on the last rule, we do have non-isolated attributes and non-isolated activities. And suppose for the moment that we have applied these 3 rules, and now we have left some activities and attributes. And suppose that we have, for example, we might end up with some kind of islands. This is how we have called, because it might be completely 2 disconnected graphs. What we are going to do, we are going to decompose this island into the fragments by starting from the activity. So we start with activity A, and we put in the first fragment everything that this activity is accessing. So it's accessing attribute 1 and 2 with occurrence X. By decomposing this island into the fragment, now we are able to apply one of the previous rules. But it might happen that some attributes might be grouped in different relation, which means that we might have one attribute which is grouped in the standalone data model class, but we might have another case that this attribute is grouped with another attribute based on the rules that we are going to apply. And for that, with the help of a domain knowledge, we are going to decide in which of these 2 options this attribute will be stored in the data model class. These slides, I will want to conclude my presentation, and I would like to say a few words about the evaluation. We have evaluated our approach on 2 real-life event logs. One of them was raw traffic fine management event logs, which is taken from an information system of an Italian policies and contains events regarding the fine creation. And another event log was a sepsis event log, which contains events regarding the patients in the hospital. After applying our approach on the first event log, in the figure you can see the discovered data model, and as you can see the root class is a fine, which then it is connected with the payment, additional payment and notification data model class, and each attribute in this class is an attribute in the event log, and by applying our approach we have grouped this attribute in the data model class. And as you can see, this information, it gives this data model gives us information which was not captured by the discovered process model. And that's why it is important to use the discovered data model to better understand an event log and as a complementary information of the business process. With this, I would like to conclude this presentation to say thank you to everyone and stay healthy. Bye.